So start.
Okay.
Show them.
I'm Tarun Chauhan. In today's session, I would like to teach a data presentation and analysis in detail. So let's begin from data presentation. First of all, we have to know that what is the exact meaning of statistics. So statistics is basically a science as well as the arts. So when we talk about the science, it's the statistics. In general, the statistics is defined as a science of collection, presentation, analysis, and reasonable interpretation of data. In general, statistics refers as a process of collection, presentation, analysis, summarizing, interpretation of the numerical data to conclude a meaningful evidence for a research study. Statistics present a very rigorous scientific method for gaining a depth analysis into a data. For example, let's suppose we have to measure the weight of 100 patients in a study with so many measurements, with so many calculation of a wide range of data. It's just provide an informative account. Statistics is also gives an overall picture of the data, which is based on the graphical presentation or a numerical generalization or summarization in respective of a data set for a study. Besides the summarization, which is another factor under statistics, there is another important task of statistics is to make the conclusions, is to make the inferences and the prediction about the comparison of the variables or to test the relationship between the variables. That is all about the statistics. So statistics is it's used in various sectors like psychology, biology, sociology, zoology, management, commerce, and many more sectors, which is equally willing to use the various tools of statistics. What is data? Data refers to a group of facts, we can say figures, which are actually in numerical in nature and just being collected for a definite purpose or a specific purpose that's called data. In today's scenario, we just came across a lot of information in the form of numbers, in the form of tables, in the form of graphs, and we can see all of these figures, tables, and graphs and numbers, and affect the facts in today newspaper, televisions, magazine, and other mode of online and offline communication, whether it's related to a cricket match or a betting or a bowling averages or the profit of a company, or you can see the balance sheet of an organization, the temperatures of the cities, the expenditure and the revenue of the various sectors according to the 5 years plan, would even in fact the polling results and so on. Everything includes data. So without data, the information sometimes becomes incomplete when it's related to a numerical values. These facts and figures, which are actually numerical, are collected for a specific or a definite purpose, and that's called data. So these are the types of data. The main two type of data is the quantitative data and the qualitative data. Qualitative data is a descriptive data where a particular individual or researcher is describing a particular issue and with respect to their solutions. When we talk about quantitative data, it refers to a numerical data where a wide range of data has been described and accordingly we just analyze and used for its own study. So when we talk about the qualitative, which is a descriptive data, are classified into two categories, that is the nominal data and the ordinal data. So when we talk about the nominal data, it refers to specify the names of the variables. Let's talk about the gender. We talk about the you can say male or female or woman and man. When we talk about the hair color of a male or a female, it's a blonde and brown. When we talk about ethnicity, it's talk about the Asian, Hispanic. So that's called where we are just naming of the variables, that's called the nominal data. When we talk about the ordinal data, here we are just naming, we are just ranking the particular variables or just giving a numbering to the variables, and that's called the ordinal data. Let's say first, second, third letter A, B, C, or the status, the economic status of an individual, that is low, medium, high, and that's called, we are giving a ranking to the variable. Let's talk about for in the classroom, the students rank for first, second, third till 10th. So that's called the ordinal data. So when we talk about the quantitative data, it's classified into two main categories, that is the discrete data and the continuous data. Discrete data is that type of data which has a particular fixed value and that can be counted. But when we talk about the continuous data, it doesn't have any particular fixed value. It refers to a wide range of data, and that is mainly measured, and that's called the continuous data. So when we talk about the examples of the discrete data, we talk about the number of students in a classroom, the number of workers in a company, the number of the total numbers of the employers and the employees in an organization, the number of house runs or home runs in a baseball or the cricket game. So when we talk about the continuous data, we are always take a variables which can be measured. Like we talk about the height of a person, a weight of a individual, any the size of a 2 BHK bedroom house, the speed of a car, and that's called the continuous data. Here we always talk about the measurements, but in continuous, here we talk about the counting of the variables, and that is the main difference between the discrete and the continuous series. Let's talk about the primary data and secondary data. It is very important to understand because you have to mention in a research paper or the research projects that whether the particular researcher would like to continue with the primary data or would like to continue with the secondary data or a mixture of both. It's a primary as well as the secondary. So primary data is that data which is a first time or first hand information which includes the personal experience and evidence which are very useful for the research by which has been done by a researcher. It also refers to a raw data or a first-hand information. So whatever the information has been gathered and whatever the assembled is very costly. So when we talk about the calculations or statistical calculation about this data, it's very expensive. So the data which is mostly collected through such source, that is, it includes the observation, physical testing, any mailed questionnaires, surveys, personal interviews, which also includes telephonic interviews, case study, and focus groups. When we talk about the secondary data is a second-hand information or a second-hand data which is already being collected or assembled by a few researchers for their own specific purpose, but not mainly for the current research problem. It doesn't portray our current research problems, which is mainly being used for our current study. So it is a sample which is collected from the various source of information, or like, for example, the government publication, the census of data, internal reports of the organization, books, journal articles, websites and reports, etc. This method is very affordable because it is easily available online and offline, which is you can easily read and available, and also save the time and cost as well. So one of the main disadvantage of this data, so whatever the information is assembled for some other purpose, it doesn't meet your present research purpose or may not be accurate. So sometimes the secondary data information or we mean may be inaccurate, which is really not useful for your current research. So that is the one of the main disadvantage of the secondary data, and that's why the researchers mainly prefer the primary data, which actually gives you the accurate results as compared to the secondary data accuracy. Let's talk about the discrete and continuous data, which is very important to understand because these types of data has been which will be included in your research project. So discrete data, it is a countable data, which is also an information that can be taken for a certain values, and they do not have the whole numbers, but they have a fixed value, such as the size of a shoes, number of teeth, number of kids, number of students in a classrooms, etc., number of schools in a city. Discrete data includes any discrete variables that are finite, numeric, which can be countable, non-negative integers, that is 5, 10, 11, and so on, 20, 25, 30, etc. When we talk about the continuous data, which do not have any fixed value, which can be measured, which includes a wide range of data, and that's called the continuous data. So continuous data, it changes over the time, over a period of years, and can have a different values at different time intervals according to the different time period as well, like the weight of a person. So if a weight of a person now it's around 80 kgs, and after a months, couple of months, it becomes 100 kg. So it changes over time, and that includes under, and that can be measurable and under a term as continuous data. When we talk about data presentation, it's mainly the two types of statistical presentation of data is graphically and numerically. So when we talk about the graphically, we use the histogram, we use the pie charts, we use the frequency polygon. So where the data set can be represented graphically through various types of graphical presentations or various types of graphs. That's called the graphical presentation. Numerical presentation, when we talk about the histograms, when we talk about the box plots, where we just classify the data and its value into a different categories, and that's called or used for the numerical variables. So when you categorize the various variables, we use the bar diagrams as well as the pie charts. Bar diagrams is also having a various types of categories, that subdivided bar diagrams, percentage bar diagrams, and etc. When we talk the most important diagram that mostly being used, that is in our researches, that is histogram. So histogram is a graphical representation of data using the bars of the different variables, whether it would be height, it would be weights, and it depends upon the height of the bars. And each bar groups numbers, it always shown into the ranges like 500 to 1000, 1000 to 6, 1000 to 1500, 1500 to 2000, 2000 to 2500. So it becomes a ranges, a difference between the ranges which shows under the histogram. In fact, the taller bars is also show that the more data falls in that range only, right? So whatever the ranges has been shown into the data set, accordingly, the diagram has to be shown into the bars and the differences of the ranges which has been shown in the data set. An histogram is also display the shape and the spread of the continuous sample data. So wherever the data would be, the large histogram could be easily made up. So this is one of the example which has been shown here, that is the histogram of a monthly sales. So you can see the frequency has been shown on the y-axis and the salary has been shown on the x-axis, and the particular ranges has been divided according to the data set, that is from the beginning from $800 to $900, 1,000 to 1,100 dollars, 1,200 to 1,300 dollars, which can be turned into the rupees as well. So accordingly, whatever the ranges has been decided or given in the data set, it has been made accordingly. Let's talk about the box plotting. These particular graphical representation is used for the numerical data or the numerical variables, right? So like for example, the mean, median, mode, standard deviation, mean deviation, so even the quotiles. So these are being shown into the box plotting because these are comes under the numerical variables. Box plot is also called the box and pixel plots or the box pixel plot. It gives a good graphical images of the concentration or of a data or a graphical representation of a data set. It always shows the extreme values which comes from the most of the data, and that could be shown through the box plotting. The box plot is constructed from 5 values, so which has been shown in the particular diagram. That is a minimum value, first quintile, median, third quintile, and the maximum value. So this is a diagram which has been shown, which classified into 3 main categories. That is the interquartile range, that is the outliers which comes under the minimum value. That is the second categories of the outliers which above the interquartile range or right side of the interquartile range, that's called the maximum value. But how to calculate these variables? It's through statistically, which has been shown on the screen. That is the minimum value. Minimum value Q1 is the first quintile minus half of interquartile range. So whatever the values has been given in the question, just divide by 2 and just subtract from the first quintile, you will get the minimum value. When we talk about the interquartile range is a difference between the third quintile and the first quintile. That means it's Q3 minus Q1. When we talk about in mathematics, the Q1 stands for 25th percentile and the Q3 stands for 75th percentile. So when you see the box of the interquartile range, the central line called median. So that is called the box plotting. So when we draw a box, we just classify the box that, and within the box, which value or which variables comes under the box. That is when we talk about the central line, we talk about the median. Below the median line, we talk about the Q1 and Q3. When we talk about the above the interquartile range, or the right side of the interquartile range, that stands for the maximum value, which also calls in other words outliers, which it stands for the third quintile plus half of interquartile range. So this is the box plotting, which has been the various variables has been shown. It includes the 5 numbers summary, which includes the minimum value, first quintile, median, third quintile, and the maximum value. So when we talk about the data set, if your data is symmetrical, that means you have to group the data in a very systematic manner. And if your data is more flatter, then means you have to check out that how your data is to be measured through statistical tools. Statistical concepts of classification, that how you classify the data, whether the data would be comes under geographical data, when we call it when it called the chronological data. So let's talk about this called the class stands for the classification of data. Classification is a process of arranging the data into a homogeneous groups that call the similar groups according to their common characteristics. In fact, the raw data cannot be easily understood, but when you classify the raw data into a particular tables or diagram, it is a very fit for further analysis and interpretation. In fact, when you arrange the raw data in a very systematic and organized manner, it is very helpful for the users to compare and analyze the data. It is very important tool for a statistical sampling as well. Let's talk about the classification of data. There are four types of classification. The first one is geographical classification, where the data are classified on the basis of location, area, region, cities, and that's called the geographical classification. The second category is chronological classification, where the data has been classified according or on the basis of time like months, years, quarterly, etc. When we talk about the qualitative classification, where the data are classified on the basis of some attributes or the quality of a you can say the common characteristics such as the gender, color of our hair, literacy, religion, ethnic occupation, and many more. So under this type of classification, the attribute under study cannot be measured. The attribute is a parameters of the, you can see the characteristics where the researcher is willing to study upon. So it can only be find out whether it present or need to be absent into the units of study. So that's called the qualitative classification, where we study the perceptions, where we study the awareness, where we study the relationships among the those variables which comes under the qualitative in nature, which cannot be measured numerically properly. Then we talk about the quantitative classification. Quantitative classification is a classification of data according to the some characteristics which can be measured. That is height, weight, income, profit, revenue, expenditure. That's called the quantitative classification. So the main difference between the qualitative and quantitative classification is qualitative cannot be measured numerically, but quantitative the data can be measured numerically. So the main difference between these two terms is it first formal classification, it can be measured, it cannot be measured numerically, but quantitative classification is measured numerically. Quantitative classification. So there are two types of quantitative classification: a discrete frequency distribution and continuous frequency distribution. Discrete, where the data can be have a very fixed, a particular fixed value can be counted, but under continuous doesn't have any fixed value. It refers to a wide data set and can be measured. But under this classification, there are two elements to know. First one is variable, and the second one is frequency. Variable refers to any sort of characteristics that varies or changes according to their magnitude or quantity. For example, the weight of the students, the height of the students, growth of a child, and that's called the variable. Variable can be discrete and continuous. Frequency, when we talk about the frequency, it refers to a number of times that each variable gets repeated. For example, if there are 50 students having a weight of 60 kgs or 100 kgs, then the 50 is the frequency, and that's called, or that refers frequency. Frequency distribution. Frequency distribution, it refers to any sort of data which classified in the basis of some variable, and that can be measured. That's called frequency distribution. So frequency distribution refers to that type of data or that type of data set which can be measured and based on some or few variables. That's called the frequency distribution, like for example prices, weight and height and wages. So when we talk that the weight is a measurable, height is a measurable, expenses is a measurable. So that comes when you show into a table, when you show into a tabulation with respected frequency or corresponding frequency, that called the frequency distribution. So in the following table, it shows the weights in the continuous. This is a data of the continuous series where the ranges has been shown from 31 to 35, 36 to 40, where the two values having some differences. That's called the continuous frequency distribution with their respective frequencies. So when we talk about the number of students is 9, that means the 9 students comes under the weight group of 31 to 35. If we talk about the 14 students, so 14 students comes under the weight group of 41 to 45. So this is called the continuous frequency distribution. If we talk about the discrete series, we talk about the number of students and the values. That is 1, 2, 3, and that, or you can say the subjects, that history, chemistry, biology, and the number of students is 10, 15, and 14. That means 14 students comes under the biology group. So that's called the discrete frequency distribution, where we are talking about the one variable and it can be easily counted with respected frequencies or two corresponding frequencies. That's called the discrete frequency distribution. This is the main concept, that is a frequency distribution. So under the frequency distribution, there are three technical terms, that is the class limits, class interval, and the class frequency. So when we talk about the class limits, it refers to a lowest and the highest values which is included in the class. So let's talk about the 31 and 35, or in the overall example, which is the lowest value and which is the highest value. So if we talk about the lowest value, it would be 31 and the highest value would be 75. But when we talk about the class limits, for example, let's take an example about 51 to 55. So lowest value is 51 and the highest value is 52. So 55. So it means 51 is a lower class limit and 55 is the upper class limits. So that's called the class limit. So here we talk about the two types of class limits, the upper class limit, which is the lowest limit, and the upper class limit, which is the highest class limit. So if we talk about 31 to 35, lower class limit, it's 31, which is the lowest value, and the 35, which is the highest value, that is called the upper class limit. When we talk about the class interval is a difference between the upper and the lower limit, and that's called the class interval. So if we talk, let's take an example, the difference between the class intervals, that is, let's say 45 to 50, right? So this is a 4 is your class interval. Let's talk about the class frequency. So the number of observation corresponding to a particular class, that's called the frequency of that class. So in class frequency is a number of students as with their respective weights. So that's called the class frequency. Measures of central tendency. So in statistics, central tendency is the descriptive summary of a data set. Of course, because central tendency is one of the measure of the statistics which always been shown in a descriptive manner. And that's called whatever the single value from the data set, it reflects the average or a center of a data distribution. It does not provide the information regarding the individual data from the data set. It also gives the summary of the whole data set. And such you can say measure of statistic, which is called the central tendency, is always being used in the various research studies. And of course it classified into three categories, that is mean, median, mode. It comes under the descriptive statistics, which not only gives the individual values but also gives the overall summary of the study through statistically, through descriptive in nature. And that's called the central tendency, which is the one of the measure of the statistics. Let's talk about the mean. Mean refers the average value of the data set. It refers to a sum of all the individual values or the data set divided by the number of values or a number of observation. If in a classroom there are 60 students who are studying the mathematics, that means, and the scoring marks is, of the all total students is 1000, that means the mean would be 1000 divided by 60. It's, you will get the mean, and that's called the exact meaning of calculating the mean. In other words, we can also call this the arithmetic mean. In fact, there are three main types of mean, arithmetic mean, that is the geometric mean, harmonic mean, and weighted mean. When we talk about geometric mean, it is a in root of the product of n numbers. It's an infinite series of numbers like 6, 7, 8. Just multiply all these three numbers, find out the root of the total value of the product of that three numbers, and when you get the root of that value, it's called the geometric mean. Harmonic mean is a reciprocal of the average of the reciprocals, so which can be explained in detail in the further upcoming slides. Weighted mean. Weighted mean, of course, the some values always contribute more than the other values in a particular data set. It is observed that whatever, or you can say, or all the values in the data set would be the same, whether it would be geometric, arithmetic, or harmonic values. So whatever the data set is given, whatever the type of mean you are calculating, the exact value of all the means will be the same. So if there is a changes in any of the data, that means the mean value will also differs. Arithmetic mean, which is always I told that how to calculate the arithmetic mean. So it is the summation or addition of all the individual values by their number of observation. So innings and runs. Runs, it's already mentioned, it's 50, 59, 98, 106, 117, 59, 91, 774. Once you add up these value and divide, the number of observation is 10. You will get the mean. You will get the arithmetic mean of the overall scores, that's called, or the innings, that is 66.1, and that's called the arithmetic mean. Harmonic mean, which is I already explained that it is the reciprocal of an average of its reciprocals. Let's take an example. The terms taken, that is T1, T2, T3 is a harmonic progression, And if it converts into the arithmetic progression, then you can calculate the harmonic mean. So in the particular question, the harmonic progression is always being given, but you have to convert your next step is to convert the harmonic progression into the arithmetic progression by dividing it into numbers. That is 1 by just reciprocal of it. 1 by T1, 1 by T2, 1 by T3. So what does the harmonic mean? There are three values, T1, T2 is 3. So the harmonic mean is a reciprocal of an average. Average is 3. So we just make it the reciprocal and of the arithmetic progression. So that is in the denominators is 1 by T1 plus 1 by T2 plus 1 by T3, and that's called the harmonic mean. So harmonic mean is calculating by dividing the number of terms, that is 3 numbers, that is T1, T2, 3, that just you can see add by the reciprocal of its term. So first you need to convert into arithmetic progression, just reciprocal of it, of the arithmetic progression, and that's called the harmonic mean. Let's talk about the geometric mean. Geometric mean is an average value or mean which signifies the central tendency of a set of numbers by finding the products of their values. So, as I already told, when you multiply the values and just find out the root of that value, total value of the product, that's called the geometric mean. So for example, for a given set of two numbers, that is 3 and 1, so just product, just you can just add it 3 plus 1 and just make a square root, that's called the geometric mean. So this is called the geometric, whether you add that number, whether you multiply that number, just find out the square root, and that's called geometric. Let's talk about the median. Median is a middle value or a mid value of a data set which has been arranged into ascending or descending order. So if there is a raw data has been given to you in the particular question, just first arrange into a ascending and descending order, then calculate the median. So if you have a skewed distribution, what is a skewed distribution? Skewed distribution, whether the three main types of the central tendency, mean, median, mode, are equal. So when we talk about the skewed distribution, these three parameters, mean, median, mode of statistics, are equal, and that's why under the skewed distribution, the best measure to calculate among these three is median, because median is a middle value of the data set. So whatever the diagram has been drawn, the middle value, the middle line of a data set is median. So that is the best measure of the tool of the statistics to find out the central tendency is median. So median, so it's very easy to understand. So when we talk about median, so it's also very less sensitive to the outlier, that is the extreme values, and it also being used to find out the extreme values, then the mean and the mode. When it's talk about the skewed distribution, where all these three values, mean, median, mode, are equal. So if the mean is 3, the mode and mean is also 3. So that's called the skewed distribution. So for example, if the family, for example, the mean of 20, 30, 40 and 990 is those 270, then the median of these four observation, that is 3 plus 40, that is divided by 2, it's 35. So what is the exact meaning is that how to calculate the median. So whatever the data has been given to you, whether it's a 4 value data, it's a 5 value data, just add it, add all 4 values, divide by 2, because median is a middle value, that is half of the data set. So just divide by 2, whatever you get the value, that is 35 item. So whatever the value, when you see the data set where the 35 lies, so that value is called the median. So where the 35 lies, that is 35 is a median, is already called 35 is your median. So when we talk about the or adding all the values, divide by 2, whatever the value would comes, it's called median. So that is the exact scenario. So median value could be odd, median value could be even. So don't be confused. It is very easy to calculate. Mode. What is mode? Mode represents the value which comes the maximum number of times in a given data set. It's called mode. So in a particular data set, if the 5 number or a 4 number comes into a maximum number of times, that's the value, that value is called mode. So under this particular example, 5 is a value of mode. Measures of dispersion. Dispersion is a state of getting dispersed and spread. So basically it tells that on which extent a particular numerical value is likely to change about the average value. It is a one of the tool to understand the distribution of the data. So when we talk about the measure of dispersion, there are four main categories. It is variance, range, standard deviation, coefficient of variation. So when we talk about variance, we can easily calculate the standard deviation. When we talk about the range, we can easily calculate the quartiles deviation or quartiles. When we talk about the standard deviation, we always easy to calculate the variance. When we talk about the coefficient of variations, we can always be calculated how much the changes occurs between the how much changes the occurs in the mean of a particular data set. So when we talk about the skewed distribution, if you see the inverse V shape, that's called the skewed distribution. So when we talk about the central value of the you can see skewed distribution, that is called median. So the difference between the median to that end of the particular skewed distribution point, we can easily calculate the variance and ranges. And when we talk about the right side of the median, we can easily calculate the standard deviation and the coefficient of variations. So whatever the distance from the center, we always easy to calculate from the median, the standard deviation, mean, coefficient of variation, mean deviations, all that we can easily calculate through these differences of the diagrams. Objectives of calculating dispersion, that it is one of the tool which can easily compare the variables between two or more variables or three or more variables as well. It also provides the reliability of an average. So whatever the small value of dispersion means that there is a low changes between the observation and the mean. Of course, the mean is a very good representative tool of observation. It's very reliable as well. So higher the value of dispersion means the greater changes or the deviations among the observation. It also controls the variability. So different measures of dispersion, it would be variance, it would be standard deviation, it would be coefficient of variation, it would be mean deviation. It always provides the variability from the different angles, and such knowledge is also helpful for controlling the variations among the observation in a given data set. So when we talk, it is also one of the bases for the further statistical analysis. The measures of dispersion is also provide the basis for further statistical analysis, like calculating the correlation, regression, test of hypothesis, and sampling, etc. Types of measures of dispersion. There are two types of dispersion: absolute measure of dispersion, relative measure of dispersion. So when we talk about absolute measure of dispersions, we always talk about the original data set. We'll always talk about the same unit of such original data set. That's called the absolute measures of dispersion. So it comes under the five categories: the absolute measure of dispersion, that is range, variance, standard deviation, quartiles and quartile deviation, mean and mean deviation. When we talk about range, it's a difference between the highest value and the lowest value. When we talk about the variance, we deduct the mean from each data and the square and add each square and divide the total number of values in a given set is called the variance. The values, the formula is already given to you: x minus population mean, the square of this difference between the mean and population mean divided by n, and the square root of this, the square of this particular value is called the variance. Standard deviation, the square root of the variance is known as the standard deviations. When we talk about the quartile and quartile deviation, the quartiles are the values that divide a list of numbers into a quarters, and the quartile deviation is a half of the distance between the third and first quartile. It means the quartile deviation is the difference between the third and first quartile divided by 2. That means half. When we talk about the quartiles, quartiles are the difference between or divide a list of numbers into quarters, like first quartile, third quartile, fifth quartile, seventh quartile, and that's called the quartiles. When you divide the half of the quartiles, we call the quartile deviation. When you classify or divide the numbers into the quarters, that is first quartile, third quartile, fifth quartile, that's called quartiles. Mean and mean deviation. So mean, which is already the average of numbers, known as mean and arithmetic mean of the absolute deviations of the observation. So mean deviation is also called the absolute deviation, and the mean deviation refers the difference between the arithmetic mean and the squares of the mean, and then divided by 2, that is half, that's called the mean deviation. So the mean deviation can be calculated by through mean and median. Range is already estimated, that is the difference between the largest item, the value, or the smallest item. So interquartile range is a difference between the upper quartile, that is Q3, and the lower quartile, that is Q1, that is interquartile range. You can see the diagram here is that Q2 is a median and Q1 and Q3 is an interquartile range. So whatever the difference between is exactly through diagram, it is a 50%. You can say the interquartile range, that means Q1 would be the 50% and Q3 would be the 50%. Variance. So variance is a measure of how data differs from the value of the mean, and variance is also as a measurement tool that how far a set of data are spread out from their mean value. So it can be calculated by mean or median. So variance is always formula, that is x, that is mean, y, that is a population mean, is square of the whole value, that's called variance. So when we talk about the variance, so square root of the variance, we talk about the standard deviation. So these are these two terms are very interrelated to each other. So when you calculate the variance, you can easily calculate the standard deviation. So without calculating the variance, it is incomplete or impossible to calculate the standard deviation, or in other words, the value of the standard deviation would become incomplete if the variance is not being calculated. So this is an example of calculating the variance. So this is a particular data set has been given to you, that is 3, 8, 6, 10, 12, 9, 11, 10, 12, 7. So calculate the mean of these value, which is 8.8. So this is a way to calculate. The mean is already calculated. The x individual data, the value of x has already been given to you. So just subtract each value, so subtract the mean from each value and then square it and then divide to the number of observation, you will get the variance. So when you square root the 7.36, you will get the standard deviation. So this is a procedure to calculate the variance. So first, the value of individual values of x has been given. Subtract the mean from the individually values of the x, then square that values one by one, whatever the total would come, put it in the formula and divide the number of observation, you will get the variance. So once you get the variance, you can easily calculate the standard deviation. Just square root the variance, you will get the standard deviation. So this is the coefficient of variation. This tool is mainly used for comparison between two or more variables. It is mainly used for comparison that how much the changes would occur between the groups and the population characteristics. It is also known as the relative standard deviation as well. And the formula of CV is a standard deviation by mean. So this is the main formula of coefficient of variation. It also gives the meaningful comparison on those scenarios where the absolute measurement tools cannot be used as well. So in fact, if the standard deviation may not be used for a research study and the coefficient of variation we use, they can easily use for the comparison, because standard deviation will not be used for the comparison. So coefficient of variation is also the another tool to make the comparison between the two main variables, and this is or two main samples of a given study. So this particular formula could be used to estimate. Quartile deviation is a half of difference between the upper and lower quartile. Upper quartile is Q3 and lower quartile is Q1. So it also one of the absolute measure of dispersion, where the how to calculate the coefficient of quartile deviation. It's a Q1 Q3 minus Q1 by Q3 plus Q1. So once you subtract the two quartiles and then add the two quartiles and divide it, it's called quartile deviation. Coefficient of quartile deviation is also used to study and compare that the degree of the variation in different situations. Skewness. Skewness is also the another measurement tool which always portray or tell us that how much the data set is symmetric or unsymmetric. So if the left tail, which is called the left skewed symmetric distribution and right skewed symmetric distribution. So when we talk about the right skewed, it's called the positive skewness. And when we talk about the left skewed, it's called the negative skewness. The skewness is a measurement tool to know that how much the changes occurs into a data set or into a data distribution, whether it would be a V shape or whether it would be U shape, whether it would be the flatter than the left side or flatter than the right side. So that tells us that how much the variations in terms of degrees, that tell us skewness. So when we talk about negative, the mode value is more than the median and mean. That is called the left skewed, that is negative skewness. So when we talk about the symmetric distribution, that these three statistical measures, that is mode, median and mean, are equal. So when we talk about the left skewed, where the shape of that curve is automatically flatter than the left side, that means the mode value of mode is more than the median and mean. And if it is happens, it's called the negative skewness. So when we talk about the right skew, that is positive skewness, which is a more flatter than the right side, that means mode is on the right side, mode is more than the median and mean, that is called the positive skewness. That is median and mean. So when we talk about if two are equal, when it means median and mode and median is equal, or three are equal, that's called zero skewness. Kurtosis is also the measure where the data is to be high-tailed. It always tells us the shapes of the particular data set being used for a study, and which is also useful for a normal distributions. So kurtosis is also the measure whether the data is a heavy-tailed or light-tailed related to a normal distribution. That is, data set with high kurtosis tend to have a heavy tails. That means a heavy gap of the data set, and data set with the low kurtosis to be light tails or lack of outliers. So when we talk about the high kurtosis shape, it is a heavy tails. When we talk about the low kurtosis, we talk the light tails or lack of outliers. So it means whatever the significance of skewness in kurtosis indicate that the data are not normal. So these are the shapes, which is when we talk about a normal distribution, data is normal. So when we talk about the heavy tail, data is not normal. When we talk about the light tail, data is not normal. The accuracy of the data set would not be come into a conclusion when we talk about the heavy tail and light tails. So that is called the kurtosis. We just need to find out that whether the data is heavy-tailed or light-tailed related to a normal distribution. So normal distribution curve is a symmetric distribution where the center, the highest peak point is median. So when we talk about the highest mean, whatever the value of the median is, highest peak point of normal distribution. So median and median, mean, and mode is all are equal. So when we talk about the heavy tailed, so it always tells us that whether the data is being accurate or lack of accuracy is being found in the data, that is heavy tailed. That means high kurtosis. So light tail, it means the low kurtosis. The more the wide gap inside the shape, that means low kurtosis. The more you can see the less gap into a you can say shape, that's called the high kurtosis. That's it. So if we talk about the kurtosis, so it always tells us about the significant shapes among of a particular data set, but it doesn't mean that such significant skewness in kurtosis is mainly indicate that the data are not normal. The data can be normal by using the kurtosis tool, or the mathematical calculation is being used to find out the data is actually the heavy tail or light tail relevant or related to a normal distribution. So when we talk about the main difference between the skewness and kurtosis, the skewness tells us that how the particular shapes is either positive or negative. Either it would be left tail, left side, or right side. So that is the exact skewness, how much the skewed of a particular data set would be. But the kurtosis is just mainly main purpose is to heavy tail or light tail, the shapes of the particular data set. So when we talk about the whole scenario, these are the statistical tools when we talk about mean, median, mode, standard deviation, mean deviation, quartile deviation, quartiles, range, kurtosis, skewness. These are all a part of the descriptive statistics. Descriptive statistics are those type of statistics where the data has been shown in a descriptive in nature, which also gives the summary of the whole data set. And it is very essential and important to use in a particular research study or a particular research projects or thesis, which always have the impact on a research study where all these parameters or all these tools will be used appropriately and give the accurate results wherever they're used by a researcher. So that's it for today, and thank you and namaste to all.